Okay, so I think we are live on YouTube as well. Um, Very warm welcome to everybody. Yeah, so it's good to see everyone. I think this is technically not the first live session because you have been interacting, over previous year's problems over other live sessions, but this will be the first session where we will have a chance to talk live on YouTube as well. Sorry, that's feedback from my YouTube being open, but all right. So, right. So I guess this is the first session where we will actually have a chance to discuss the assignments from this edition of the course. So I think very recently we have had the deadlines for the week 1 and week 2 assignments sort of get over. So those are the assignments that I plan to discuss. But before we get started, I just wanted to check in with all of you. What's your general sense of how the course is going for you? Is it too difficult, too easy, the assignments boring, or are you finding them to be doable, or is it too crazy? Any feedback that you have will be helpful for us to calibrate things going forward. So so please let me know any general thoughts that you might have about the course at this point. Those of you who are on Zoom, if you would like to unmute yourself, that would be fine too. But my guess is you're also welcome to just use the chat. Okay, so you're saying your full day goes on this course. Okay, all right. So that makes it sound like it is getting to be a bit intensive, I guess.
Ma'am, actually, I wanted to add one thing. I'm beginner also. That
Oh.
may be one more reason.
Okay, so have you done a programming course or an algorithms course before?
Yeah. Basic I have completed, but data structure and algorithm I am very first doing from this course.
Right. Okay, so yeah, I think this course definitely would be a little bit easier for people who have had some prior exposure to, say, data structures and algorithms. If you're learning that side by side, I would say it is possible, but like you are experiencing, I think it does become a little bit hectic, a little bit on the challenging side, right? So, but on the plus side, you'll probably end up learning a lot, so maybe that's a good thing. But yeah, let us know if there's any way that we can make things easier. I expect that, me and the TAs will be around on Discord, and I'm guessing that you have access to Discord and you're actively using it. That's one way of making things a bit easier, by talking about the course and the materials with others. Nilesh is saying the learning curve is a bit steep. The problems are top notch. Some more problems could be added in non-graded coding assignments for practice. Yes, that's a great point. I think we used to have a course website where, we used to have a list of recommended problems for everybody to try, which were relevant to sort of each of the individual chapters. And I think that is still there. So just give me a second. I should be able to pull it up. So the non-graded thing.
Hi, ma'am. Nilesh here.
Yeah. Hey, Nilesh. Yeah.
So, ma'am, currently, as per the topics that are being discussed, that have been discussed in week 0 and week 1 and week 2 respectively. What I felt was that in the searching and sorting, the assignments and questions, we could have added a bit more of a interjecting medium problems in between. Somewhere I felt that the level just came from easy medium to just a medium hard. There was not a medium in between. Is what I felt.
I see. So right. So what you're saying is there was a bit of a sudden jump, which makes it
yes, and more like focus could be on the other data structures also, like the stacks and queues, which have like a good usage, which were I guess not discussed in depth. Is what I felt.
Yeah, correct. That's a good point.
Priority queues, stacks, entries, those were things that could have they are very much used in optimization problems. So
yeah, no, I agree. In a certain sense, you're absolutely right. Unfortunately, we are kind of I mean, again, in competitive programming specifically, unfortunately, stacks and queues don't come up as much, although they're really wonderful data structures to work with, and they do come up implicitly when you're doing things like
Yes, yes, ma'am. Yes, ma'am.
so, which is kind of why. So again, NPTEL has a lot of great courses on focused completely on data structures and algorithms, where you get a lot more exposure to the more traditional materials you're talking about, like stacks, queues, heaps, balanced binary search trees, and things like that. And this course is kind of what we kept in mind was for people who want to get started with either the informatics Olympiad or with ICPC. The idea was to get them sort of jump started with common sort of topics. And unfortunately, pure data structures usually don't show up as much. They usually show up in the context of some algorithms.
Like in case of like any hybrid problems, like, because like priority queues are something which are used in greedy algorithms also. However, I couldn't find any of the problem which was like any greedy problem which was using priority queues or heaps. So in that way, like, if like more and more questions, like if they're added for practice, then implicitly some more data structures also would be in practice. We will get into practice, but again, that would like boil down to the quantity of problems as well, is what I felt.
Right. Well, I mean, at least priority queues do show up when we talk about shortest paths using, say, Dijkstra's algorithm.
Yes, absolutely, ma'am. Yes,
so I think if you just hang in there, hopefully they'll show up in a little bit. But for everything else, point well taken. I think it would be nice to have some, if not mandatory material, at least some supplementary material that takes a detour into data structures and just emphasizes those aspects. So, yeah, so thanks for that feedback, Nitesh. We'll definitely keep that in mind. And Rohit is saying that you're able to solve the programming assignments easily, but the quiz problems are a bit difficult and are taking a lot of time. So it's possible that we have kind of tipped the balance, because last semester, I think the feedback was that the programming assignments were much harder to do. So we probably focused on making those a little more accessible, but now I mean, the quiz problems, I think, for instance, the first week is always a bit tricky because it's just ad hoc, right? So we just end up having some fun with puzzles and things like that. But as we go along, I think the quizzes will be more systematic and will be more directly based on the lectures. When you're talking about week 1 and it's ad hoc, you can really ask any question. So that's any question, as long as it's reasonably self-contained and just puzzle-like. So it's understandable that those may have, thrown some of you off a little bit. But I think the remaining quiz questions will kind of stick to the materials more closely. So you should hopefully the quizzes will get easier and not harder. So, but nevertheless, kind of pass that on to the team. And I'm also usually involved fairly in creating the questions. So I'll keep that in mind myself as well. I think there's a question in the live chat as to whether a replay will be available. So that's, I think, the question from Sean George. And yes, the replay will be posted on NPTEL after this session is over. So in case you have to leave for some reason, you can always catch up later. Okay, so if there are any other questions or comments, then we can discuss those. Otherwise, I will see if I can get my iPad screen to show up here, and maybe we can start with discussing problems from week 1 and week 2 and things like that. Let's see. So, right, everyone. Sorry, I need a minute here. But let me just, in the meantime, try and recap the problem that we are going to be solving. So let's try and focus on the first programming assignment in week 1. So the first programming assignment was about a game involving stacks of boxes. So did anybody on the call kind of solve this one? And if yes, do you want to like share your approach? Then that would be a good place to start. Especially while I'm trying to set up my screen. Prashant, yes. Let me just share this link with you here. Just give me a moment. In fact, I think let me just show you how to navigate this website. So this is the course website outside of NPTEL. We'll try and see if we can get these materials, also inside of, inside of NPTEL. But the idea is that here, I believe, we have a breakup, a week by week breakup, where within each week there is basically a list of problems that you can try out on Codeforces, CodeChef, AdCoder, and similar platforms. Yeah, Nilesh, I think unfortunately my screen share is behaving a little strangely today. But nevertheless, I think what I'll do is I'll just drop this link here. But hopefully by the end of this week, we will try and see that these links to these problems are actually put up also within the NPTEL website. So you don't have to go anywhere else. You can just look them up right from within NPTEL. So we have a list of about 4 to 5 problems for every week that are suggested practice problems. And in fact, many problems are actually suggested by the community. So we used to ask on Discord if people are trying out problems that have a similar theme, or if they have recently solved a contest where some ideas from some week were useful. And, learners from the course would often share such problems with us, and we would kind of bookmark them and add them to these lists. So I think we will just add a link to this from within NPTEL. I'm not sure if that course link actually shows you the list of problems right now, but I will make sure that you have access to that before the end of this week or something like that. Okay. All right. So I think with that, maybe let's just try and get started with the first problem from week 1. Let me actually just share my desktop screen because I'm not able to share my iPad screen at the moment. So just give me a minute. The only thing I'm not sure about is how well, like you can see the font size here, just like, is this reasonably visible where it says week 1, problem 1? Okay. I have a feeling that the font size may be a little bit small, and I'm not completely sure how to enlarge it, but
it is fine enough.
It's fine. Okay, great. All right. So I think this was our first problem. And what we said was, so yeah, thanks everyone for confirming. So in the first problem, we start off with a stack of n boxes, and you make a sequence of moves, and you can divide one stack of boxes at any point, which has more than one box. If a stack has just one box, you cannot do anything. But if any stack in front of you has more than one box, you can take it and divide it into 2 non-empty stacks. Okay. And you can sort of keep doing this in any order you like. And at the end of the day, you have n stacks with each of them having a single box. At that point, you are stuck. You cannot make any more moves. And in each move, you earn, points based on how you divided the stacks. Okay. So if, for example, you start off as is shown in the example here, if you start off with one stack of height 10, and then, you divide it into two stacks of sizes 5 and 5, then you get 25 points, which is the product of the sizes of the two smaller stacks that you got, right? So that's the scoring or the point system. That's how you earn points in this game. And well, of course, in this example, we say, okay, this is how it plays out, and you get 45 points. Can you do something better? And it turns out that you actually cannot do anything better in this case. I should have said it's a bit of a spoiler alert. And I think what you want is, given the number of stacks, given the size of the first stack, you want to know what is the maximum possible score that you can earn. Okay, so let me just quickly ask if anybody solved this, anybody on the call solved this, and if yes, what was your answer? Okay, so Manas says n into n plus 1 by 2 minus n was your final answer. Let me write that down. So the answer in terms of code is actually really simple. It's like just an expression. Rajesh is saying n into n minus 1 by 2, which looks a bit simpler to write. So let me just write that. I think Manas, your answer works out to be basically the same. Yeah, if you work it out. And okay, let's just think about like what's the logic for this. The interesting thing about this game, which is what we hoped everyone would discover, is that it actually doesn't even matter how you break up the stacks, although you might have realized yeah, you might have come up with a strategy which just says, pick the largest stack and divide it roughly in half or whatever. But actually, what you can prove is that no matter how you break up the stacks, you end up basically, coming up with the same score. And if you want to actually formally prove this, this is a nice proof by induction, basically. This is something that you can do. But nevertheless, I think, okay, so Pushpender, any k gives the same value. I assume you mean that no matter how you break this up, like no matter how you play this game, you end up with the same final score. Is that what you mean? Okay, let me just pause the screen share and check if there are any comments on YouTube. Okay, I don't think there's anything very specific to this. So, all right. Okay, so Pushpender, that's what you intended to say. So, okay, so how would you, does anybody have a sort of a logic for how you arrive at this figure, n into n minus 1 by 2, or whatever the other expression was, which amounted to the same thing?
Ma'am, what I have done is that, like, first I have taken some examples, like I have taken 1, 2, 3, 4, 5, and so on. Then I have calculated their result. And from the result, I have tried to generalize via help of n. Means like we do in arithmetic progression or some sort of that.
Okay, fair enough. So what you're saying is basically you observed some examples, saw that there is a pattern, and kind of identified the pattern from there. That's fair? That was sort of your approach? And I think that's absolutely fine. So for example, let's say that, okay, so just to pick up on what you said, working with an example. So let's say, for instance, you start with n equals 8. I think there are two sort of natural ways to play this game. One is to break a stack into as equal sizes as possible. So for instance, you might start with 4 and 4 in the first step, and that gives you a score of 16. Then you might say, okay, let's break this up into 2 and 2. And that gives you, okay, let's see, we're adding up the points in each step. So let's say this gives you 4, then 2, 2, 2, 2, that's another 4. And now you just keep getting, I think you will get 4 more points if you do this 4 times. You take each of these stacks of size 2 now, and you break them up into 1, 1, 1, 1. This will give you a total of 4 points. So if you think about this, how many points do you have? Okay, somebody do the addition and tell me. In the meantime, let me just try another way of breaking this down.
36.
Okay. How much did you say? Is it 28 or 36?
It's 28 supposedly.
28, yeah. Yeah, again, I hope that the numbers are kind of visible, but all right. So the other way to do it is to say, okay, always break it up into a stack of size 1, for instance, and the rest. So this would be 1 and 7. This gives you a score of 7. And then you say, okay, 1, 1, 6. This gives you a score of 6. Then you do 1, 1, 1, 5. This gives you a score of 5. Need a little bit of patience, but let's just go through it. 3, this gives you a score of 3. This gives you a score of 2. And finally, hopefully I got the number of 1s right, but this is what you have. And now again, the score here is going to be the sum of the first 7 numbers. So that's going to be 10, 15, 21, and 28. So you might think, well, I mean, is it just an interesting coincidence that we played this game in 2 very different ways, but we still ended up with the same score? So what the interesting thing is that it really doesn't matter how, how you break things up. The claim, if you like, let me see if I can put this in a box or something. So the claim is that no matter how the game is played, the total score ends up being, I know you were asked for the maximum score. I'm just saying that you don't even have to worry about the maximum. No matter how you play it, you will kind of end up getting essentially this number, which is oops, yeah, something like this, which amounts to, I think, the value that you had earlier, n into n minus 1 by 2. Okay. The sum of the first n numbers is like that number times that number plus 1 by 2. So in this case, it'll be n into n minus 1 by 2. So that's one interesting fact about this, but essentially, how do you prove something like this? You can sort of prove this using induction, where you say, okay, so suppose, so let me continue writing in slightly bigger font. So suppose the first move breaks, n into a plus b. It doesn't really matter what a plus b is, but by the, most of you know induction as a technique, right? When you do proof by induction to prove things like the sum of the first n numbers is blah, blah, and things like that. Is everyone okay with proof by induction? Yeah, okay. All right, let me know if, anyone is not comfortable with that terminology, but essentially using the induction hypothesis, what you can say is that the score that you're going to get from the left pile is going to be something like a into a minus 1 by 2, plus what you're going to get from the right pile is going to be b into b minus 1 by 2, plus what you get from this step itself is going to be something like AP. And now you can expand this, work it out, and it'll work out to being n into n minus 1 by 2. Okay, so it's not just that you have somehow hit on some optimal way of doing it. Actually, no matter how you do it, it ends up being optimal, which I thought was pretty cool. But once you have this expression, this is all that you have to write out. So it's just like really a single line of code, which returns the appropriate value. But this is a fact that you don't really need for solving the problem. But I think this is one of the reasons we included this problem, is that this is kind of a cool fact. You could actually try and play this game with a friend of yours, saying, maybe you go ahead and do this, I'll go ahead and do it some other way, and we'll see who wins. And if they don't already know this fact, it'll kind of be surprising that nobody can ever win or lose at this game, because no matter how you play it, you'll always end up with the same score. Okay, so let me know if that was okay, if that was clear, and then we can move on to the next problem. I'll just take a break to check if there were any comments on YouTube. Okay, Arun, I can see n into n minus 1 by 2 now. That's great. I'm glad if it made sense. Okay, those of you who are on Zoom and if you're tuned in on YouTube, please give me a +1 if you think this was okay, this made sense, and we can move on to the second problem from week 1. Okay, fantastic. I think we have a lot of +1s. So it looks good. Thanks, Arun, as well from YouTube. Okay, cool. So let me just go back to sharing my screen here. All right, so I think what we have here is this problem, which I think was maybe in its formulation, perhaps a little bit confusing. But let's see. Okay, so you have n cups of gulab jamun arranged in a circle at some party, and a fly is sitting in one of the cups at the moment. After minute number k, the fly jumps over k minus 1 cups clockwise and lands in the next one. For example, after the first minute, the fly ends up at the neighboring cup, and after that, the third cup from the start, and so on. And what you want to know is, will the fly visit all the cups or not? Okay, cool. Let's just try and see what is going on here. So let's see if I don't have a emoji for gulab jamun, but maybe we have one for coffee. So again, like somebody said, maybe a good idea to do it through an example or something. Okay. Let's see. Spacing is a bit bigger. So I think here we have 10 cups, and the first cup is invisible because all right, sorry, Srajan, will I be sharing this explanation document? I actually could, but there's not like, I mean, I'm not being very detailed and working anything out. Maybe I can try to give you something proper if there is interest. Sure, I mean, we typically do share solutions of some form after, after the deadlines are over. So let me look into that. But yeah, I mean, as just as a rough thing, I'm happy to also share this, and the video will also be sort of available. All right, so Suresh and Manas already have the answer in terms of powers of 2, and let's just try and understand sort of the logic for this. So you have to kind of imagine that these cups are in a circle. We'll kind of be wrapping around. So, but let's see. Just to make sure that the sort of the process is clear. So after minute 1, the fly jumps over k minus 1 cup. So when k is 1, the fly jumps over 0 cups, lands on the next one. So let's assume that clockwise is going right. And as I said, you have to use your imagination to imagine that this line is actually a circle. Okay, so so we have this sort of a situation, I think. Please correct me if I'm wrong, but after minute 1, this is what happens. After minute 2, the fly jumps over 1 cup and lands on the next one. So it's going to jump over this one and land here, I think. Okay.
Ma'am, it will jump on second cup, no? Means
Yeah.
just after the fly.
Yeah. So it's all together on the fourth cup after the second minute.
No, ma'am, I don't think.
Oh, I see. Okay. Just give me a second. Okay. I also want to make sure that I'm not, okay, maybe I should make it a slightly smaller example, but
And also at first minute, it will be on the same cup only. Means it will not jump on the next cup.
uh, well, okay. Let's see. I think want to be a bit careful in terms of interpreting this. So after, okay, so even in this example, what we have written in the problem statement is that after the first minute, the fly ends up at the neighboring cup, right? So this is after the first minute, because I'm just parsing out what's written here, right? After minute number 1, the fly jumps over 1 minus 1 0 cups, which is you don't skip anything, right? And you end up at the very next cup. Is that making
Means
sense?
first cup.
Yeah, but the next one to the first one, right? So that's like you start somewhere and then you're at the next cup. Does that not make sense? Let me just see if, like, I'd shared an animation in Discord to clarify like the movements of the fly. So let me see if um, that's consistent with what I'm saying here. But okay, so anyway, in terms of like the high level idea that we are interested in, those of you who are saying it's powers of 2, I do believe that the answer is along those lines. The idea is to kind of figure out so the fly keeps doing this jumping forever, but the crux of the matter is that beyond a point, the patterns of which cups the fly is visiting essentially end up repeating, right? So that's what we want to kind of understand as far as at least this problem is concerned. But I'm just trying to see if I was consistent in how I described the movement of the fly on when somebody had asked for a clarification on Discord. Okay, this has been a while, so I'll have to scroll back up quite a bit. Okay, can I just okay, so I think this is sort of I don't know if this animating sequence is visible, but look at where the fly is right at the beginning at this point. So this is when it's at the top. After 1 minute, it's at the very next one, then it skips 1, then it skips 2 to go there, and then it skips 3 to come back here. Okay, so that is the sequence that I had in mind. So let me see if I can fix what I had on where I was writing it out. Um, Sorry, guys, I'm just doing a little bit of typing up front so that I can share this directly. Okay, so all right, I think we seem to have like slightly conflicting interpretations. But let me know if you agree with like, so this is by start, I really mean at minute 0, if you like. Okay, so this is where the fly is to begin with at the very first position. The way I interpret it is after minute number 1, the fly jumps over 0 cups clockwise and lands on the next one. So you could think of it as, so basically the number of cups you jump over is like basically how many do you hop, how many do you skip basically before you go to the next one. Okay, so you're always moving. I presume you don't come back to the same cup exactly. You after minute 1, you hop over nothing and you just move to the next one. So this is why after the first, so this is kind of a clarifying example, right? After the first minute, the fly ends up at the neighboring cup. And then this, I think, is what happens after that is that you skip over 1 cup to end up at the next one, right? Which means, well, I think this third cup from the start can be a bit confusing in the sense that, I mean, dropping 3 cups and then coming to the, I mean, this is, you could argue that this is the 4th cup from the beginning, but I think the idea is that here you skip from wherever you are currently, you jump over, like, so after the 2nd minute, you jump over 2 minus 1 cup, and then land up over the next one. After the 3rd minute, what happens is you're supposed to jump over 2 cups. So remember this in a cycle. So you jump over this one, and you land up at the next one. And then after minute 4, you're supposed to jump over 3, and then you land up here. Is this sequence making sense? Just let me know if you agree with this being the correct simulation, at least. Okay, so Rohit says yes. Let me just pause this for a second and check if there are any comments on YouTube. All right, thanks for joining, Arun. I think Arun had to drop off. And there are no other comments on YouTube, so we'll just go back here.
Ma'am,
Yeah.
I should assume no that the cup to the left of fly and the fly are in combination, no? Means the fly is sitting on that left cup, the cup that is left to it. I should take it like that, no?
Sorry, how are you interpreting it?
Means I am saying that while I am seeing the fly, I should interpret it that it is sitting on the cup that is left to it. Means left the cup left to the fly and the fly itself are in combination, just left.
Okay, so okay, this is okay, let me know if I understand you correctly. So the cups are indexed like this, right? So from, let's see, so 1, this is the first cup, the 2nd cup. Okay, maybe a little more convenient to think of them as being indexed starting from 0, I guess. Yeah, sorry. So now can you explain? So I'm assuming that to begin with, the fly is inside the cup that is indexed 0. And then after the first minute, it moves over to the next cup, which is cup number 1. Does that not make sense?
It makes sense. I assume I understand because I am taking it wrongly. Now I understand. No problem.
Okay, I mean, maybe it's just like an indexing issue, but hopefully it's just, I don't know. Yeah, if it's something that is consistently off by 1, or something like that, then maybe it doesn't change the expected answer. But let's yeah, let's see what would be the best possible interpretation. I think this is, I mean, especially given, I think you could argue whether this should have been like the third or the fourth cup from the start. I think I may have said third cup because of sort of the indexing. So like basically at the first position, I mean, at the first unit of time, it's at position 1 and then it's at position 3 and so on. But all right, so for those of you who are saying that this works out as powers of 2, okay, so at least one intuition is that, you know, if you simulate this for long enough, you'll basically, okay, once you come back to the start, I mean, you're going to see the same pattern over and over again, which is why I think somebody pointed out that maybe if you have not visited a cup, then you will never visit the unvisited cup. So let's actually see how that works out. After a certain number of after minute 5, you're going to skip over you know, you're going to skip over 4 cups to come back to exactly where you started, right? So this is not going to make, you know, you just keep coming back. You know, it's just going to keep coming back to the same position. So let's just try and see if, okay, so what happens when the number of cups is in fact a power of 2? Let's see. Yeah, I'm also wondering now if my indexing here is off by 1. Okay, so Rohit, what you're saying is if a fly visits a cup a second time, and in the meantime, if any cup is not visited, the fly will never visit the unvisited cup. Yeah, it does seem like here, for instance, the cup that is indexed by 2, right? That's going to remain unvisited. At least in this simulation, it's kind of clear that that's never going to happen. But let's just see what happens.
But ma'am, for a large number like 8 or 16, if I have done that, it is not happening like the same, like it is happening here.
Oh, you're saying, okay, so Rajesh is saying that it's enough to check for the first n over 2 minutes. Okay, so all right, let me just let's look at what happens here. After minute 2, you have landed up on the third cup. After minute 3, now you should be skipping 2. End up here. Okay, so all right, so for we'll get back to your question about larger numbers, but at least for 5 and 4, do you agree with these sort of simulations? Okay, sounds good. All right, so so one logic for, you know, kind of pursuing, I mean, saying that you don't, I think one of the questions that also came up on Discord was like, for how long do you need to simulate it to be sure that, you know, you've identified a repeating pattern in some sense, right? So let's just say that, you know, after okay, after the first, so let's try to track the position of the fly after, you know, after k minutes, right? So what's going to happen? So just imagine that this is like, you know, really like n is really large. Okay, so what is the best way of figuring out the index after k minutes. So after the first minute, we see that the index is 1. Now, after that, you're going to, after that, it's going to be 3, which is essentially, you skipped 1 and you went to the next one, right? So essentially, so here I would say you skipped 0 and you went to the next one. So that's why the index is 1. Then you skipped 1 and you went to the next one. So I hope this is clear, right? So you skipped 0 and this is the cup you land up at. Then just imagine that you're counting the cups, right? And you're counting the index. So in the second step or in the second minute, what's happening is that you're skipping over 1 cup. So that is index 2. And then you're landing at the third one. So that's another 1. So that's what's happening at the second minute. At the third minute, you're skipping 2 and you're landing at the next one. At the fourth minute, you're skipping 3 and you're landing at the next one, and so on and so forth, right? So for example, just to make this maybe a little more explicit, so let's say that this was like we were working with a much longer array of cups. Okay, so what would it be after minute 3 in this example? So after minute 3, remember it's going to skip 2 and then move to the next one. So the fly is going to come here. And then after minute 4, what is it going to do? It's going to skip 3 and move here, right? So that will be the new location of the fly. So it's going to skip 3 and move here. All right, so if you trace sort of the indices, it's going to be something like 1 and then 3, which is essentially 1 plus 2. And then it's going to be 4, 5, 6, which is 1 plus 2 plus another 3. That's what you're going to add here. 7, 8, 9, 10. You need to add another 4 to account for the 3 skips and the 1 landing and so on, right? So, so I hope in terms of, so after minute K, the index of the cup you are at is going to be like 1 plus 2 plus 3 plus 4 and so on up to K. Is this kind of making sense in general? We have to figure out the wraparounds for sure, but let's just argue that at least this is making sense.
Ma'am, one more thing I would like to ask. Like in second minute, it is said that it will fly over 1 cup and land the cup next to it. So we can also interpret like this, where the fly was initially, like it was in cup number 1. So it fly over it and then jumps to next cup. Can we take it like that, or it is wrong?
Okay, so I think just to avoid any language-based ambiguity is why I think we made it explicit that what happens after the first minute is that it's at the neighboring cup from the one that it started. Okay.
Okay.
So, right, your interpretation is that it jumps over nothing and comes back to its original position. Is that what you're saying?
Means for which minute you are saying?
So I'm talking about what happens after the first minute. Which one were you talking about?
I'm talking about the second minute actually. I'm thinking that as you are counting, like it flies over from cup 1, then it crosses the cup 2, then it landed over cup 3. I am saying like it should fly over cup 1, means we should assume that it is already crossed 1 cup, then it will land on cup 2. So both are.
Oh, I see. No, but it's not going to fly over a cup that it already is on, right? It's going to jump over. So if you just substitute after minute number 2, the fly jumps over 1 cups clockwise and then lands on the next one, right? So I think this is reasonably clear. that, where were you at the previous minute? At the previous minute, you were at cup number 1. And what you have to do now is that you have to jump over 1 cup, which is clockwise, to land at the next one. At least that's my interpretation. To say that you are jumping over the current cup is, I think, not, I don't know. I think that seems like a slightly unnatural interpretation of the English to me. But in any case, okay, this is just for the future in general. If you have a confusion like this as to how to interpret the language of like the procedure that's happening, then, please feel free to just post a message saying that it's not clear how the fly is moving. So here, at least what we try to do, because I think somebody did ask, what is going on here. And I don't know how helpful this was, but, what I was trying to say is that, again, I'm not sure how visible this is. Let me see if I can zoom this in. So you start at the top, okay? In the first step, you move 1 step to the right, then you skip 1 and you move to the third one. Then you skip 2 and you move here, and then you skip 3 and you come here. That's kind of what was happening, okay? So, and again, if it's still not clear, we can try to make it more explicit. But yeah, essentially, it would be hopefully not a language ambiguity that makes the problem easier or harder for you. But okay, so so let me just describe at least the high level idea as I remember it when we were, kind of considering this problem. The idea is that the index of the cup that you are at after k minutes is basically the sum of the first k numbers. At least that's how the skips are supposed to be designed. And so, for example, and of course, once you've gone around the circle, you'll have to do essentially a mod n, because the number is too big, so you don't have that many. So you'll have to get rid of how many ever multiples of n there are to get the actual index, right? So the point is that if you go up to 2n minutes, right, then the sum of these numbers, in fact, this might already happen at n minutes. Yeah, I mean, basically, if you sum up to n, you're going to get a number which is kind of a multiple of n. And once that happens, you know that a multiple of n mod n is basically 0, which means that you're back to where you started, right? So, yeah, I mean, that's why it's kind of enough to kind of simulate this for the first n or 2n minutes. Something like this should be enough. And you can do this either by brute force, because basically after that, what's going to happen is once you're back to the start and your jumps involve skipping, let's see, in the example that we had, unfortunately, the amount of skipping that you were doing was exactly the number of cups left. So in like when we were doing it with 5, the fly kept was coming back to the position that it started with. But essentially, once you're back to where you started, you're not going to see anything new. So that's why it's enough to simulate this for the first 2n minutes or so. And if during that process you see that something is left out, then there is no hope of covering it in the future. This is something that that one can argue, because if that point were to show up, it would have shown up in the first 2n minutes. This is what we want to argue. And yeah, essentially, Rohit, what you were saying is kind of what I'm saying, except that instead of going to an arbitrary cup a second time, I'm just saying it's guaranteed to come back to the first cup where it started, right? So if you take the sum of the first, say 2n numbers, then you're going to, and you do a mod n, then you're going to come back to index 0. So you'll never have to do more than that many. Because once you have kind of closed that loop, it's not very difficult to check that you'll kind of end up not making any new visits. So all the visits that you have made so far would actually, in fact, be already accounted for. So you can do this sort of by direct simulation. But it turns out that there is this interesting sort of connection with the powers of 2, in the sense that the pattern that you might end up discovering is that if n is a power of 2, then the first n-1 minutes, the jumps that you experience will all end up being at different locations, which actually means that if there are, so of course you start out at cup 0, and then you have n-1 locations left. And if in the first n-1 minutes you end up at n-1 different locations, that means that you have in fact visited each location. Okay, so basically, you can, I mean, this is something that you can argue. I'm not sure, for those of you who discovered the power of 2 pattern, whether it was by observation or whether you actually argued it numerically like we did for the previous example. There was an induction based proof that no matter how you do it, you always end up with a particular score. Here also what you can do is basically say that, okay, look, suppose n is a power of 2, and within the first n-1 minutes, there are 2 distinct minutes where you end up at the same location. Okay, so then based on that, you can do some calculation which will lead you to some sort of a contradiction. And on the other hand, if your number is not a power of 2, then you can actually argue that there will be a specific location that will get missed out. So that is kind of true as a numeric pattern. And I'll see if I can write up like a bit of a something like a proof of this fact, and that definitely leads to a much faster sort of algorithm, because all you have to do is check if n is a power of 2 or not, like some of you were doing. But even otherwise, this is possible to do by simulation. So the only thing that I think was being shared on Discord is that I ran it for so many minutes, but how can we be completely sure that that is enough? That maybe if I simulated this process for a few more minutes, maybe I would have landed up on cups that I have not discovered yet. So for that, the argument is what I was trying to present here, which is that after the kth minute, you are at the sum, your index is the sum of the first k numbers. And once that k is chosen to be such that this number is divisible by n, that means that you're essentially 0 mod n. So you're back to where you started. And from there on, you can basically convince yourself that once you come back to where you've started, after that, there is nothing new to be discovered. Okay, which is the same intuition that some of you were giving in the chat, that once you have repeated a cup, then anything that is unvisited so far will remain unvisited forever. Okay. All right, so I realized that some parts of this were vague, but at a high level, the expected solution for this was essentially by simulation. But the trick, I guess, was that because the language of the statement says that the fly keeps doing this forever, you might wonder, well, for how long do I need to simulate it to be sure that I really have not visited everything? And for that, I think you just, either heuristically by working out examples or using your intuition or using a proof, you can basically cap it at something like n or 2n. Okay, so all right, so that was kind of the expected solution. But once again, if you dig a little deeper, there is a nicer numerical pattern to this also. And if you discover that, then you can actually get away with just checking if n is a power of 2 or not. Okay, so please give me a +1 if at least some of this made sense. I promise that I'll do a nicer sort of a write-up offline and share it on Discord in a couple of days, since I realize now that maybe the language on, what exactly the fly is doing was not completely obvious, but let me see if I can clarify that a little bit more. Okay, so thanks. It's great to know that at least some of it is adding up and is making sense. Okay, so I would have loved to go on to the week 2 problems or some of the week 1 quiz questions. I think from Discord, what I understood was that the median question was not obvious, because the definition of the median given in the question was ignored and the general definition of median was being used perhaps. Or maybe there was again something in the framing that I may have missed, I'm not sure. So I think there was a request to discuss question 9 from the week 2 quiz. And also I think in general, I guess there were some questions based on games. And for example, I think I had given an example of this number game where who is the first to reach 100? If we just start telling numbers and the first number is between 1 and 10, and the next number is always between the next 10 numbers and so on. And in the example that I'd given, player 2 was winning. And in the answer, we said that player 1 has a winning strategy. So I think the point that may have been missed for people who were asking, how can player one have a winning strategy if player two is able to win, is that the definition of a winning strategy does not imply that you win every single game. So if you have a winning strategy, but you don't play smartly, right? So for example, in tic-tac-toe, both players have a drawing strategy, but sometimes people still lose tic-tac-toe because they're not playing carefully. That doesn't mean that you don't have a strategy. So that is something that I would like to clarify, Aram. But right now, I'm afraid we are running out of time because it's over the hour, and it's probably dinner time for many of you. So perhaps let's see. I think there was one suggestion to have an additional live session. I'm not sure if that's too much for you folks. So Rohit, it turns out that for this particular game, you kind of have to work it out. For most specific games, you really have to work it out. And for many games, it's not at all obvious. So I had asked about the game of Sim. So in the game of Sim, when you play it with 6 vertices, it turns out that player 2 has a winning strategy, but it's a highly complicated winning strategy. Okay, so, and nobody till date has been able to figure out how to simplify it so that somebody can remember it and play according to it. So this is not an easy question. It depends on the game, but there is for a specific game. So for example, like the 100 game, like who gets to 100 first, there is a very simple winning strategy where basically you can reverse engineer it by saying that, okay, if I want to get to 100, it's enough for me to get to 89. Okay, why is it enough for me to get to 89? Because if I can reach 89, then the other player can only play a number between 90 to 99. And no matter what they play, I can play 100, right? So for me to get to 100, it's enough to get to 89. And by a very similar argument, you can see that to get to 89, it's enough to get to 78. And to get to 78, it's enough to get to, I think, 67. And then to get to 67, it's enough to get to 56, and so on and so forth. So you can keep backtracking, okay? And so that will lead you to a strategy. So the first player can say, I play 1. Then no matter what you play, I will play 11. Then no matter what you play, I'll play 23. You can keep doing this. I could be slightly wrong on the exact numbers because I'm speaking a bit fast, but essentially this is the idea. So player 1, I mean, no matter how player 2 plays, if player 1 chooses to play in a particular way, they can always guarantee a win for themselves, okay? And another interesting thing about games is that there is a theorem which says that, if you're playing a finite game and, you have the appropriate assumptions, then the game is like one of the players will always have a winning strategy or both players will have a drawing strategy. It's never that that this is not the case. So that's a fascinating theorem in game theory. In case you're interested in such things, there's some very nice material out there. So if you send a message on Discord, then I will remember to maybe send you some pointers. But for, I think the 100 game, which came in the quiz, the strategies as I was trying to describe. But I do realize that this is a bit rushed, and it's rushed mainly because I don't want to hold everybody up beyond the hour. What we can do is see if just for this week, and again, I'm happy to do this based on demand. So if some of you feel that it would be useful to have an additional live session to discuss the week 2 problems, I'm happy to do that as well, maybe over the weekend or some other time that's convenient for everyone. But for now, I would like to wrap this up just in the interest of time. And as I said, I'm sorry if the fly argument was not very convincing. What I will do is try to write this up properly so that you have it for reference and you can look it up later. But I hope that, at least the discussion gave all of us some intuition or some idea of how to go about it. Okay. All right. So more soon. We'll keep in touch. Thank you, everybody, for joining. It was lovely meeting all of you. For me, effectively, the first time in this run of the course. And I hope we get to do this often. And I'm also happy to do informal voice sessions on Discord if enough of you are online and you want to have a quick discussion. Generally happy to do that as well. So feel free to self-organize ad hoc meetings. And I look forward to keeping in touch with all of you. So thank you so much. And we'll wrap this up here I will definitely have a live session next Tuesday at 7 p.m. If we schedule an extra live session, I'll definitely let you know in advance. All right. So thanks very much. Good night, everyone. And keep in touch over Discord and talk soon. So I think we can stop the live stream as well and close this session now. Thank you.